Hi everyone, welcome to the next section. Now that you have mastered completing the square, I'm going to show you a much easier method. And please don't get mad at me that I didn't show you this sooner, but I did want you to learn completing the square process. Some geniuses in the past have taken a really difficult quadratic, like something like this, and tried to do the completing the square process and said, oh, this is so complicated. So what they did, really smart, was they took this equation, ax squared plus bx plus c, and all the steps that you do to complete the square, they did with the letters. For example, when they moved this 1 over here and it became negative, right? So 2x squared plus 5x equals negative 1. When they moved that over, they moved this c over, so it became negative c on that side. And then when they divided everything by 2, they divided everything by a, right? By a, just to show you, to give you an idea. So if we were together in the classroom, I would actually do this step by step by step by step, but it really isn't necessary. I'm just going to tell you that they did each step with the letters and then simplified and simplified and simplified, which could get pretty complicated. And after they finished that, they came out with this wonderful formula, which you may be familiar with. Ta-da! Here it is, the quadratic formula. And you were hopefully introduced to this already, but that's okay, we need to review it. Everything ended up being here. So x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. I have a handy little tune you can sing to this so that you can memorize it. You want to memorize it, trust me. So the tune is Pop Goes the Weasel, if you know that. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And there you have it. Sing it, hum it. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And if we were in class together, I'd make you sing it with me. Aren't you glad you're watching this on a video instead? Now, what this means is, all you have to do is take a quadratic, figure out what a is, what's b, what's c, and plug them into this formula. And what will come out are your x's or your zeros. There's your solutions. All right, so here's our first attempt to try to do this. There's a problem, and that is that this is not set equal to 0. It's not the correct a, b, and c unless it's set equal to 0. So we need to move this 4 over first. So this becomes 2x squared minus x minus 4 equals 0. Now we know our a is 2, our b, let me write this down here. Our a is 2, our b is negative 1, okay, negative 1, and our c is negative 4. So now just sing it in your head while you write these down. So x equals negative b. If b is negative 1, then negative b is the opposite of that, or positive 1. Negative b plus or minus the square root of b squared. Now be careful. Because b is negative, there are some students who've got negative 1 or negative 5 or whatever it is squared like this, and their calculator said the answer was negative 25, and they wrote negative 25 here because they didn't realize that the calculator didn't include the negative. Just remember, your b squared will always be positive, always, because even if b is negative, a negative times a negative will be positive. So in this case, b squared is 1, b squared minus 4 times a times c. There we go, minus 4ac all over 2a, 2 times 2, which is 4. All right, now you just simplify. When you simplify, remember of order of operations, do this first. You have negative 4 times positive 2 times negative 4, that's 16 times 2, that's positive 32. So what you have then is this 1 plus 32 is what that simplifies to be. If anybody has problems, it's there. 1 plus 32 is 33. So what this becomes is 1 plus or minus the square root of 33 over 4. And that's what x equals. And that's your answer. And you're done. That's it. Totally irrational, would be very difficult to find and not fun in completing the square or anything else. But with this quadratic formula, you can figure it out just like that. So 1 plus the square root of 33 over 4 and 1 minus the square root of 33 divided by 4. And you can actually approximate those with a calculator if you had to graph them or round them to the nearest 2 decimal places or something. That's what you would do. You would go 1 plus square root of 33, enter, divided by 4, that would give you one answer. Then go 1 minus the square root of 33, enter, find that number, then divided by 4, there's your second answer. And that's how you could approximate to the nearest 2 decimal places or actually plot them on a graph if they ask you to do that. But that's how to use the quadratic formula. Here's another problem. If I was given this, I would not use the quadratic formula because factoring is easier. If you can factor this, you can come up with your answer so quickly. For instance, if you know that this is x plus 3 times x plus 3, there is your solution is right there. You know x plus 3 equals 0, it's got to be negative 3. You can practically do that in your head if you can factor. But I want you to see how the quadratic formula will work. It'll work for all of them. So let's walk through it. A is 1, B is 6, C is 9. So x equals negative b plus or minus the square root of b squared minus 4 times a times c all over 2a. And a is 1, so that's 2. So 4 times 1 times 9, that's negative 36. 36 minus 36 is 0. So the square root of the square root of 0 is 0. So we have negative 6 plus or minus 0 over 2. And that's just negative 6 over 2. And that's negative 3, which is what I told you by factoring. But you see, you got the same answer. Quadratic formula worked. Now I'm going to show you how to apply this to a real world kind of situation. This quadratic here represents the profit that a club or an organization can make depending on how much they charge for a certain item that they want to sell. Like it could be a band that sells CDs they made or something like that, or a craft store selling whatever. But depending on the price that they market, that would affect their profit. So let's say this organization says, what's the least amount we could charge and still make a profit of $200? In this case, my capital P stands for profit. So in order to find out what's the smallest amount they could charge and still make a profit of 200, I have to make P 200. So 200 equals this equation. Set it equal to 0. Now use the quadratic formula. Here's all the numbers that I plugged in. Now I'm going to simplify it. So this became 48 squared minus, and 4 times 500 is 2,000. This is a negative 2,000. So 48 squared minus 2,000 is how we got 304. And now negative 48 plus or minus the square root of 304 over negative 2. Enter those into your calculator one at a time. What two numbers do you get? And here's our two solutions. We have two solutions because of the positive and the negative. One solution when we added the square root of 304 and the other solution when we subtracted. And we see that if we charge $15.28, we can make a profit of 200. And if we charge $32.72, that would round to the nearest penny, $32.72, it would also make a profit of 200, which may seem weird, but think about it. If you charge this much, you're going to sell less. If you charge this amount, you'll sell more, and that's what is taken into consideration. So if you're looking for the smallest amount that you can charge and still make $200, you're going to charge $15.28 for this fundraiser. Now, because this formula has this plus or minus in this square root part, this square root section becomes really important. Everything inside the square root is significant. It's called the discriminant. We call it the discriminant because you can use it to discriminate how many solutions you're going to have, because it's inside of this square root. So think about that. If I go b squared minus 4ac and I end up with a negative number, can I have a square root of a negative number? And your answer is, at this point, with what you know right now, the answer is no. So therefore, if this discriminant is negative, then there are no real solutions. So you would have an example of, if you have a quadratic and it never crosses the x-axis, this b squared minus 4ac would end up being a negative number. No solutions. So if this is negative, so if this is less than 0, there's no real solutions in that type of situation. If you plug in b squared minus 4ac and you get exactly 0, which we did earlier, you got exactly 0, then that means you're going to have negative b plus or minus 0. So it's just going to be negative b over 2a. That's only going to be one number. So if you end up with it equaling 0, you will have one solution. This will be one solution, because you've taken out that plus or minus type of situation. And with the same type of reasoning, if b squared minus 4ac is a positive number, any positive number, anything greater than 0, then you know you're going to have two solutions. Just going to be two, because you're going to have the positive of that square root and the negative of that square root. So this would be two solutions. And if they're perfect squares, then they would be rational, and otherwise they would be irrational. So you can even tell if they'd be rational or irrational numbers. If this is a perfect square number, positive number like 36 or 25 or 49, you know, that type of thing. So the discriminant can really tell you quite a bit. So you may get a quadratic like this, and you may be asked what are the number of solutions that this quadratic has. You would use the discriminant. You would use the b squared minus 4ac. And if you have trouble memorizing the discriminant, just remember it's the part of the formula inside the square root, all right? So a is negative 2, b is negative 3, c is 5. So b squared, and I'll just do it this way, negative 3 squared minus 4 times negative 2 times 5. So this is positive 9. And this becomes positive because I have a negative times a negative, and it is 8 times 5 or 40. So positive 40. So my discriminant is 49. It is positive, so I have two solutions. It is a perfect square, so I'm going to have two rational solutions, right? Just two whole numbers. It'll be nice and easy when I do that. And so now I know it has two rational solutions. I don't think you're going to be asked if they're rational or irrational. Just the fact that it's positive, has two solutions, is probably all they're going to ask you. Let's walk through one more just for practice. B squared minus 4ac of this one. In fact, why don't you try it? Go ahead and pause the video, find the discriminant of this, and tell me the number of solutions it has, and then check in and see how you did. Okay, so you should have done b squared. B squared is 9 minus 4 times a times c. Now this is negative. 4 times 2 is 8 times 7, so you have 9 minus 56. That is a negative number. So you're going to have what, negative 47? Whoops, negative 47. Because it's negative, I hope you said there are no real solutions, because you can't have a negative square root. So the answer would be no real solutions. So how did you do? Here's another one for you to try. This is your lesson check. Be careful. Notice it is not set equal to 0. So it doesn't give you an accurate B and C yet until you set it equal to 0. How many solutions does it have? What's the discriminant would be good, and how many solutions does it have? That's your lesson check for today. Okay, here's how we would use the discriminant in a real life type of situation. This quadratic models the flight of a golf ball that is hit at an initial velocity of 85 feet per second. I think it's 85 feet per second. Let me check that. It is. So this is 85 feet per second, and the time is in seconds. And the question is, will this reach a velocity of, a height, will the ball reach a height of 115 feet? So in place of h, put 115. Now set it equal to 0. Now use the discriminant. Are there solutions to this, right? That's what we're looking for. Will it reach that height? Is it possible? So use the discriminant to see if there are solutions. B squared minus 4ac. So b squared, 85 squared, minus 4 times negative 16 times negative 114 and 11/12. These numbers look terrible, but your calculator can do this. So when we do that, 85 squared is 7225. These three numbers added up are negative 7,354 2/3. And notice this number is bigger than that one. My negative is bigger, so my answer is going to be negative, which means I have no real solutions. Since there's no real solutions for 115, we know that the flight of that golf ball will never reach a height of 115 feet. It has no solutions. So that concludes section 4.7, all on the quadratic formula and the discriminant and how to use both and apply them in all kinds of situations. You are not having to go through complete the square this time, so it's a little simpler. So have fun with that and practice it, because it can get complicated in simplifying that discriminant. And I will see you guys next time.